If you are a developer, you may have already heard about memory leaks. Now let's see what is memory leak. Memory leak is nothing but a terminology when there are some variables or functions or events that have occupied some memory. And in practicality, the work is done, but the reference is being used somewhere, and that is stopping the garbage collector from removing those variables and functions from memory. The reason is garbage collector thinks they are still in use. Now, this uncleared memory is called memory leak. Before we understand memory leak, let's understand how memory is assigned. There is mainly two types of memory, stack and heap. There are other types of memory as well, but as we are objects and variables are going to be stored in stack and heap only, we will only be talk about stack and heap. All the object type data like functions, objects, arrays are stored in heap memory, and variable like strings, number, and reference of object from heap memory while pointers are stored in stack memory for faster access. Now, what are pointers? You can search on Google or watch videos on YouTube, or I may create a video on pointers as well. When we run a web app, variables and objects get memory assigned, and once the job is done, the garbage collector removes those from memory. Now, what I mean by this statement, let's suppose we have a function. Inside that function, we are declaring two variables, variable 1 and variable 2. Both have number values. And we are creating another variable, variable 3. Now, what variable 3 has is a sum of variable 1 and variable 2. Now, after variable 3, we are just simply console logging value of variable 3, which is sum of variable 1 and 2. Now, after definition of that function, we are calling that function. Now, when we call the function, our JavaScript engine will go line by line, as our JavaScript engine is single threaded. So it will go to the first line of that function, which is declaring a variable 1, after that declaring variable 2, and after that declaring variable 3. Inside that variable 3, it is doing sum of variable 1 and 2. And after variable 3, there is a line which is console logging value of variable 3. Now, after that execution finishes, our garbage collector will scan the memory and check if the work of that function is done or not. If the function work is done, garbage collector will remove the definition of that function, and the variables that we have created inside that function also will be removed. But in some cases, like closures, the garbage collector fails to remove that variable as long as the function that is using that variable is in memory. Now, what are closures? You can just Google them or watch videos on YouTube as well. But if you are a developer, I think you should already know about closures. There are major four factors that can cause memory leak: self-declared variables, closures, events, and set timeouts and set intervals. Today we will only talk about events. So when we attach an event with event listeners to any element and we run the code in a browser, it calls a web API, as events are not part of our JS V8 engine. It is run by browser outside our V8 engine. We'll understand this statement with this diagram. This is little diagram which I'll be explaining from top to bottom. Don't worry. Here is a little snippet of a React code, which is a component named window resize watcher. Inside this component, we are using useEffect, and inside useEffect, we have declared a function named handle resize. And inside that function, we are simply just console logging a string window resize. After this function, we are attaching an event listener to window object, which event is resize event, and on resize event it should trigger our handle resize function, which is this. Now let's suppose for now we don't have any clean function inside this component or inside our useEffect. So what will happen here is this function will go into, will take space into a heap memory. Uh, Definition of this function will be stored in a heap memory, and the reference of this function will be passed to a stack memory for fast readability, and that reference will be passed to are this line. Now, this line, add event listener, this line will go to a wait engine, and wait engine will execute this line window.add event listener. Our event listener is resize and our function is handle resize. Wait engine doesn't handle events. So this line after executing will be passed to our web API, as web API is the one responsible for our events and callbacks. So web API has a registry called event listener registries. Now what will happen here is it will register a resize event for the window object, and it will pass the reference of a function handle resize. Now after giving reference of our function, it will execute that event, and that execution will go to a callback queue. Now what will happen after that is the reference of handle resize function will stick to the event. Which event? Our resize event for the window object, until we close the tab or remove event listener from window object. And as long as event has reference of our handle resize function, garbage collector won't be able to remove the definition of function from heap memory, and this will cause memory leak. What I mean by this is our event registry has reference of our handle resize, which is this, and the definition of a handle resize is defined inside a heap memory. So as long as its reference is passed here, and you know that events won't get clear by our garbage collector. At garbage collector is part of our v8 engine, and web API is totally different thing. So garbage collector will only scan our memories, and it will check if uh, our function is being used or not. So what garbage collector will think is the reference is passed to our event. So garbage collector will think that this function is still being used inside an event, and it won't be clear definition of this function. So this will cause a memory leak. Now, so how we can solve this? What we can do is we can just return a cleanup function inside a use effect. Use effect provides this functionality that whenever component unmounts, use effect will return a cleanup function. So inside we are returning a function which is a cleanup function, and inside this cleanup function we are removing our event from window object. Now this will remove our resize event from window object inside our event registry, and this will prevent from memory leaking. So I hope you understood how memory leak works and how you can prevent it. There are few topics left, like self-declare variables, closures, and set timeouts and set intervals, which I'll be covering in future. So if you want to learn about those, stick to my page.